Hello everyone, this is Miss Lindsay. Today we're going to talk about the equidistance theorems. These theorems will definitely help shorten a lot of your proofs that you've been working on currently. Before we get into these theorems though, we need to talk about a couple definitions. The first is the distance between 2 points is the length of the shortest path joining them. So if you think about if you're in lunchroom and you need to get around these tables, you would take the shortest path around to get to see your friend on the other side. That would be the shortest path that you would take. Okay, so the shortest path between 2 points is what we call the line segment joining them. If there's no obstacles in the way, for example, like the lunch example where you have tables of friends. Definition: a point is said to be equidistant from 2 other points if the segments joining the point to each of the other 2 points are congruent. There's a lot to that, and we will go ahead and do a shortcut to that. The shortcut to that would be if congruent segments, then equidistant. So what would that look like? So let's start with point P. We would say P is equidistant from points Q and T if we know that P is congruent to both Q and the segment between P and Q is congruent to the segment PT. So P is equidistant from Q and T. Moving on to another definition. The perpendicular bisector of a segment is the line that is both perpendicular and bisects that segment. So again, putting those two terminologies together. So if we take a look at something that would be a perpendicular bisector, so we have AB would be the perpendicular bisector of TQ if it bisects it and forms right angles as well. Now let's go into our theorems that are definitely going to help us again shorten our proofs. If 2 points are each equidistant from the endpoints of a line segment, then the line joining them is the perpendicular bisector of that segment. And then we can go reverse with that as well. So if a point lies on the perpendicular bisector of the line segment, then it is equidistant from the endpoints of that segment. So let's go back up to the first theorem here and draw an example of this. Okay, so if 2 points are equidistant from the endpoints of a line segment, then the line joining them is the perpendicular bisector. So if 2 points are equidistant, so my 2 points would be, this point is equidistant from the 2 on the left and right, this point is equidistant from the 2 on the left and right, then the blue line would be the perpendicular bisector of that purple line. So the blue line would be your perpendicular bisector. Another example of that could look more like this. So again, if this point here and this point here are equidistant, which in other words congruent from the endpoints of a line segment, then the blue line would be the perpendicular bisector of that horizontal line. Now let's look at the second theorem. I have a diagram drawn here. If a point lies on the perpendicular bisector of the line segment, then it is equidistant from the endpoints of that segment. So I'm given this diagram. BI is the perpendicular bisector of RD. Therefore, we would know that B is equidistant from R and D, as well as I is equidistant from R and D. So let's move on to our first example. Go ahead and pause the video and please label all the information on the left-hand side onto the diagram and then push play when you're ready to resume. Okay, so with your diagram marked, we know the given information. We know that MT is the perpendicular bisector of IE. And since the point M lies on the perpendicular bisector, we know that MI and ME are congruent because M is equidistant from I and E, as well as IN and EN would also be congruent. So I would like you to go ahead and pause the video, go ahead and set up your system, solve your system, find x, y, and the value of 4x squared minus 5y squared. And when you're done, I can tell you that x should be equal to 3, y would be equal to 2, and the value of 4x squared minus 5y squared would be 16. Moving on to the next example. Here we're given that UB is the perpendicular bisector of GM, so again, perpendicular and bisector. Go ahead and pause and then please label everything else on the left-hand side on your diagram. Okay, so now that everything is labeled, again, going back to the fact that UB is the perpendicular bisector of GM, we know since B and U are on the perpendicular bisectors that they are equidistant from both the points G and M. So we can mark our diagram accordingly. From that, we can now see that UG would be congruent to UM. So we can set up our equation. If we solve that for x, we should get x is equal to 5. And now we need to find YB. So working on finding YB, we can see that we have a right triangle here. Okay, so if we're trying to find the right triangle, we know this side would be 11. Setting up Pythagorean theorem, x squared plus 3 squared equals 11 squared. We can then solve that for x and simplify, so we would get x equal to 4 square root 7. Moving on to our first proof, we have our first given statement here. We have triangle ABC that has side AC is congruent to side CB. Therefore, we can say that angle CAB is congruent to angle CBA by if sides, then opposite angles are congruent. We can move on to our next givens. AF bisects so AF bisects angle CAB, and BF bisects angle CBA, also given. Because we have double bisect and we have the larger angle CAB is congruent to angle CBA, we can now say angle 1, I'm going to go ahead and label the little angles here, angle 1 is congruent to angle 2 by if congruent angles, then like divisors are congruent. Okay. Because now we have that, we can now use the reverse and say AF is congruent to BF by if angles, then opposite sides are congruent. So let's take a look at our diagram here. So now we have these sides are congruent. So as you can see that we have C is equidistant from both A and B, as well as we have F is both equidistant from A and B. So those would be our next steps. So we would say, from step 1, we would have C is equidistant from A and B if congruent segments, then equidistant. From step 6, we could get F is equidistant from A and B, same as 7. And from both of those, we can now say that CF is the perpendicular bisector of AB. And the reason would be if 2 points are equidistant from the endpoints of a segment, then they form the perpendicular bisector of the segment. Moving on to the next proof. Here we have our given statements. GE is congruent to KE. We also know that GM is congruent to KM. So we can now say that E and M are equidistant from K and G. Okay? And that would be if congruent segments, then they are equidistant. Because E and M are both equidistant from G and K, that then leads us to EM is the perpendicular bisector, so EM is the perpendicular bisector of GK by if 2 points, E and M, are equidistant from the endpoints of a segment, then the line joining them is the perpendicular bisector. Then from the diagram, we can assume for step 6 that H lies on EM. Again, looking at our diagram, H lies on EM, which is assumed from the diagram. Therefore, H is equidistant from the endpoints of the segment, GK. If a point lies on the perpendicular bisector, which we showed in 6, then it is equidistant from the segment's endpoints. Which then leads us to GH is congruent to KH. If equidistant, then congruent segments. So let's go ahead and take a look at this diagram. Typically, you're going to see this diagram frequently, as well as you can see that this is like a shape of a kite. If you go to our next example, that's an inverted kite, where that segment is now taken and then brought up on the perpendicular bisector. So again, you can see we're going to see these diagrams quite frequently. So this last example, I would like you to go ahead and do this for class. And this concludes section 4.4 on equidistant theorems.